Now here's a trick that helps a lot of times. So let's check out number 13 and try to factor that out, and then we'll talk about what's happening or how to do this. Okay. So first of all, I see there's a common factor of 5 here. So I'm just going to bring that out to the top. So I factor out a 5, and then I have x minus y left, right? On the bottom, I factor out a 4, and I have y minus x left. So x minus y, y minus x, they're similar, but are they the same? If it was x plus y and y plus x, that would be the same, right? Because the commutative property works with addition. But it's not the same with subtraction, right? There's no commutative property of subtraction. 3 minus 2 is not exactly the same as 2 minus 3, right? And you can use any two um, integers that aren't the same, and that's going to be the case, all right? So they're opposites of each other, but they're not exactly the same. So what we can do is we can actually factor out a negative. So what I can do is I can say, okay, well, let me factor out a negative 1 here. So I'm actually going to make, let's do the numerator, okay? So I'm actually going to make that a negative 5, and then the x will turn negative and the y will turn positive, right? Okay, so if I divide this and this by negative 1 and bring the negative 1 out front, then the x becomes negative and the y becomes positive. All right, so that's essentially what we're doing. And now we have a situation where we have a match, right? So there's a package deal, and now we have the same package on top and bottom, and so we can cancel those out, and we end up with negative 5 over 4. Okay, all right. So sometimes you can factor out a negative 1, and that flips things around, and you might be able to cancel some things out, right? And so notice that what changed is the sign, right? The sign changed from being a positive 5 over 4 to a negative 5 over 4. Okay. All right, let's try number 14. So I'm going to factor out the numerator. Now, I don't see a GCF there, but it's a difference of squares. So it's going to be m plus n, m minus n, right? So on the bottom, I have n minus m. Well, it's pretty close, right? We have the same two values, but they're flip-flopped. So what we can do is factor out a negative. So now, if you want a shortcut, you can actually just cross this out and then just put a negative in front. That's sometimes what I'll do if I'm trying to go quickly, or if I'm on a standardized test or something and I'm running out of time. That might be something that I do. Okay, and that's fine with me if you do that. Just show me that work. What I'm going to do is I'm going to bring it up here, and I'm going to factor out a negative, and so that'll be n minus m. Flips it around, and so then I can see that these cancel out. And so remember, there's this negative is actually a negative 1, right? So if this goes away, it turns into 1, right? Anything divided by itself is 1. So then I have negative 1 times m minus n. So I can either write that as negative m minus n, or I can write it as, m plus n. Or I can write it as negative m minus n, right? I can basically distribute that negative 1, and so that would give me a negative m minus n. All right, and that's it. Let me know if you have any questions. Just kidding. We have one more problem left. Thought that was it. So factoring out the opposite of a common factor. So reduce the lowest terms. So here we go. So here, notice how the w squared is our highest power here, and it's with a negative leading coefficient. So I'm going to factor out a negative 3 here. Okay. And so I'm going to factor out negative 3, and actually w is a common factor as well, right? And so then I'll get 1 plus w. Okay. Then on the bottom, and I can't do anything more with that, so I'm just going to bring it over. So I usually put if I have a GCF, I factor out on top just in case there's more I can factor. But here we couldn't factor anything more. On the bottom, we have a difference of 2 squares, right? W here, square root of 1 is 1. So we put a 1 there, plus here, minus there, okay? Now here, there's nothing that we have to do with 1 plus w and w plus 1, right? Those are the same things, right? We talked about 3 minus 2 and 2 minus 3. The commutative property for addition is works, right? So 2 plus 3 is the same as 3 plus 2, okay? And so these actually are the same. So we can just cross them out. And so we end up with negative 3w on top and w minus 1 on the bottom. Okay, sometimes people might write that as negative 3 or negative in the front, and then 3w and w minus 1 there. So either way is good. All right, so now we're done, and you can let me know if you have any questions. Feel free to email me or ask me in class or come into office hours, okay? Here's the strategy for reducing rational expressions, excuse me. So if you didn't get this before, you can pause the video and write it down now.